Hello dear plasmatic friends. Today another logarithmic equation, but a little bit more difficult. Follow me please. First of all, we identify that we have an equation and that is a logarithmic equation. Then I will see if I have only one term on the left side and only one term on the right side. Unfortunately, here I have one term separated by a positive sign of another term. Then I have to think how to get only one term on the left side and only one term on the right side. So I can see that if I pass this logarithm to the left side, I can use the logarithm properties. So I will do it. Logarithm base 2 of 9 to the power of x minus 1 plus 7. And here, minus logarithm base 2 of 3 to the power of x minus 1 plus 1 is equal to 2. Now remember please, when you have a subtraction of logarithms, you will make a division. Then logarithm base 2 of this expression divided by this expression. And now I can work. I can start because I have only one term on the left side and only one term on the right side. Then how to eliminate a logarithm base 2? Well, I will put a base 2. But if I put a base 2 here, I will also put a base 2 here. Then base 2 with logarithm base 2, goodbye, and I will have 9 to the power of x minus 1 plus 7 divided by 3 to the power of x minus 1 plus 1 is equal to 2 to the power of 2. Now I can pass this expression to the right side and we will have a multiplication. Then I will write 9 to the power of x minus 1 plus 7 is equal to 2 to the power of 2 is 4 times this expression, 3 to the power of x minus 1 plus 1. And here I see that I have an exponential equation. And how to solve an exponential equation? Well, first of all, we are going to multiply this monomial by this binomial. Then I will write 9 to the power of x minus 1 plus 7 is equal to 4 times 3 to the power of x minus 1 plus 4 times 1, 4. Please pay attention. You cannot say 4 times 3, 12. Never, because you have an exponent with letters here. So you leave 4 times 3 to the power of x minus 1. And 4 times 1, yes, 4. Please pay attention here, because you cannot start an exponential equation if you have more than one term on the left side and more than one term on the right side. Here I can see that it's impossible to get only one term on the left side and on the right side. But I see that if I pass everything to the left side, I will get a trinomial. And if I have a trinomial, I can solve that equation. So I will do it. 9 to the power of x minus 1 minus 4 times 3 to the power of x minus 1 plus 7 minus 4 is equal to 0. We are passing everything to the left side with the opposite sign. Now we solve. Set minus 4 is 3. So 9 to the power of x minus 1 minus 4 times 3 to the power of x minus 1 plus 3 is equal to 0. And here I can see that we have a quadratic form for this equation, because 9 is 3 squared. So I can write 3 squared to the power of x minus 1 minus 4 times 3 to the power of x minus 1 plus 3 is equal to 0. And here remember, when you have an exponent rise to another exponent, the exponents will be multiplied. So you write 3 to the power of 2 times x minus 1 minus 4 times 3 to the power of x minus 1 plus 3 is equal to 0. And remember, when you have here an exponent that is twice this exponent, and here you have the same base twice the exponent of the same base raised to this exponent, and another term that is alone, only one number here. Then, if we have a quadratic form, we can solve it with factorization, with quadratic formula, or completing the square. So I prefer factorization. So we are going to factorize this trinomial. We are going to find two expressions that are multiplied will give us 3 raised to 2 times x minus 1. And two expressions that multiplied will give us 3. So remember that the first sign will be this sign, and the multiplication of both signs will be here. Negative times positive, negative. Now I need to find two expressions that multiplied will give us this expression. 3 to the power of x minus 1 times 3 to the power of x minus 1 will give us 3 to the power of 2 times x minus 1. Because if you have x minus 1 and x minus 1, you will get 2x minus 2. 2 times x, 2x, 2 times negative 1, negative 2. And that's the same, so it's okay. And now 3 times 1 is 3. We are going to verify it. Remember our video of factorization of a trinomial. Then we multiply negative 3 times 3 raised to the power of x minus 1 is negative 3 times 3 to the power of x minus 1. And here the same. 3 to the power of x minus 1 times negative 1 times 3 to the power of x minus 1. So, negative 3 of something plus negative 1 of something is negative 4 of something. Okay, so our factorization is correct. Now we are going to verify that our factorization is correct. Then we are going to multiply. Negative 3 times 3 to the power of x minus 1 will be negative 3 times 3 to the power of x minus 1. And here the same. 3 to the power of x minus 1 times negative 1 is negative 1 times 3 to the power of x minus 1. Then negative 3 of something plus negative 1 of something is negative 4 of something. Perfect. So our factorization is correct. Then we are going to write those parentheses. 3 to the power of x minus 1 minus 3 times 3 to the power of x minus 1 minus 1 equal to 0. And when you have factors multiplying that are equal to 0, you will write the first factor equal to 0 and the second factor equal to 0. And here you have two simple exponential equations. But in order to solve an exponential equation, you need only one term on the left side and only one term on the right side. So here I can pass the negative 3 to the right side. So I have 3 to the power of x minus 1 equal to 3. And here the same. 3 to the power of x minus 1 is equal to 1. Now, how to disappear a 3? Well, I will write logarithm base 3. But if I write logarithm base 3 on the left side, I will write logarithm base 3 on the right side. Then logarithm base 3 with 3, goodbye. And I will have also logarithm base 3 with 3, goodbye. But pay attention, here you have exponent 1. If you can't see the exponent, it's 1. So you will write x minus 1 is equal to 1. Be careful, please. Not 0, 1. Because you eliminate this part, but the exponent is 1, so you write 1. Finally, you pass the negative 1 to the right side, and you will get x is equal to 1 plus 1, that is 2. Here we will do the same thing. In order to eliminate a 3, you write logarithm base 3, because we have seen that in our video of properties of logarithms. And here you will write logarithm base 3. You eliminate that and you get x minus 1 is equal to, and please remember the properties of logarithms. Logarithms base anything of 1 is always 0. Then the answer will be x is equal to 1. And please remember that when we are solving logarithmic equations, we need to verify that the answers are correct, that we are not writing a logarithm of a negative number or logarithm of a 0. If we replace the x with 2, 2 minus 1 is 1, 9 to the power of 1 is 9, plus 7 is 16. Logarithm base 2 of 16, no problem. 2 minus 1 is 1, 3 to the power of 1 is 3, plus 1 is 4. Logarithm base 2 of 4, no problem. So here we have a correct answer. And if we replace with 1, 1 minus 1 is 0, 9 to the power of 0 is 1, plus 7 is 8. Logarithm base 2 of 8, no problem. And here 1 minus 1 is 0, 3 to the power of 0 is 1, 1 plus 1 is 2. Logarithm base 2 of 2, no problem. So we have the correct answers. Thank you very much, dear Fastmatic friends. See you next time.